Hey everyone, so voice assistants and speech recognition, they're literally everywhere, right? On our phones, in our homes, even in our cars. It can feel like pure magic, but it's not. It's actually the result of some seriously impressive engineering. But that begs the question, how do they actually learn to understand what we're saying? To figure that out, we're going to pull back the curtain on the disciplined engineering journey that goes into building a production-ready AI. We'll use a voice assistant as our guide. Okay, let's jump in. You see, building something that really works for millions of people isn't about just, throwing a bunch of data at some super fancy algorithm and hoping for the best. It takes a structured, repeatable process. And in the field, this is what's known as the machine learning project lifecycle. Every single journey has to start somewhere, and for this one, it all begins with a really solid plan. So, the very first step in this life cycle is called scoping. You can think of this as the blueprint phase, is where engineers get super clear about the exact problem they're trying to solve. For our voice assistant, the goal seems obvious. Build a speech recognition system for voice search. But the real work here is defining what good even looks like. And that means defining the key metrics. Accuracy, well, that's a no-brainer. Does it get the words right? Throughput is all about scale. Can it handle millions of users at once? But latency? Now that one is huge for user experience. I mean, if you ask a question and have to wait 5 seconds for an answer, the magic is just gone. It needs to feel instantaneous. So, scoping, data, modeling, and deployment. That's our roadmap. We've got the blueprint nailed down from the scoping phase, so now it's time to gather our raw materials. This brings us to a stage that many experts will tell you is the most important one of all, the data. A machine learning model is only ever as good as the data it learns from. Seriously, think of it like cooking. You could be the greatest chef on the planet, but if you start with rotten ingredients, your final dish is going to be terrible. And this leads to a challenge that's way more complex than it looks. Just take this simple phrase, today's weather. Okay, if you were writing that down for an AI to learn from, how would you transcribe it? It seems like a tiny little detail, but your answer has massive consequences for the AI's performance. I mean, should you include the or should you just ignore it? Maybe you should just label it as noise. Any of those could be a perfectly valid choice. The absolute worst thing you can do, though, is be inconsistent. If you have different people labeling your data, and a third of them do option 1, a third do option 2, and a third do option 3, you're basically just confusing your algorithm. Consistency is everything. And this really gets to the core lesson of the data stage. It's often so much better to perfect the labels on the data you already have than to just go out and collect terabytes of messy, inconsistent stuff. When it comes to training a really good AI, quality truly beats quantity. All right, so we've got our blueprint, we've got our high-quality ingredients. Now it's finally time for the modeling phase. This is where we actually train the brain of our voice assistant. Now, in the machine learning world, there are kind of two main philosophies for how to get better performance. There's the model-centric approach, which is all about endlessly tweaking the algorithm's code. But for most real-world applications, what's called the data-centric approach is just way more effective. And why is that? Because the model's code can only do so much. It's the data that actually teaches it about the real world. Think about it this way. You can take a really solid, well-understood model, maybe even an open-source one that already exists, and just by feeding it exceptionally clean, consistent, and well-labeled data, you can get incredible performance. It's a really practical and, frankly, powerful strategy for building systems that actually work reliably. So we did it. We've trained a model that performs beautifully on our test data. But, the lab isn't the real world. The final and maybe scariest step is deployment, releasing our system out into the wild for actual users. So what actually happens when you talk to your phone? Well, first, a simple little algorithm on your device just detects that you're speaking. It then sends only that little audio clip up to a massive server in the cloud. That server does all the heavy lifting. It transcribes the audio, and then it sends the text and any results right back down to your phone. And all of that has to happen in the blink of an eye. But here's the catch. The real world is not static. It is constantly changing. And this leads to a really critical problem in machine learning called data drift. Basically, it's when the data your model is seeing out in the real world starts to look different from the clean data it was trained on. So what causes this drift? Well, imagine our voice assistant was trained mostly on adult voices from California. What happens when a ton of teenagers from Scotland start using it? Their pitch is different, their accents are different, their slang is totally different. The model's performance will start to go down, not because the model is broken, but because the world it's living in has changed. And this brings us to the final, and I think most crucial piece of the puzzle. This whole process, it's not a straight line from A to B, it's a circle. It is a continuous loop of improvement. You just don't deploy a model and then walk away. Building a great AI product is all about constant iteration. You have to be monitoring, learning, and adapting to the world as it changes. And this is exactly what that loop looks like in practice. Teams are constantly monitoring performance. When they spot that data drift, like, hey, the system is struggling with teenage voices, they go out, they collect new data, they label it consistently, they retrain the model, and then they deploy the new and improved version. And then the cycle starts all over again. So after all that, what are the big takeaways from this journey? First, real-world success isn't luck. It requires a structured lifecycle. Second, high-quality, consistent data is probably your most valuable asset. Third, adopting a data-centric mindset will get you further faster. And finally, never, ever stop monitoring your system once it's live. Kind of makes you think, doesn't it? The next time your phone's camera magically identifies a face in a photo, or a translation app just works instantly, you can appreciate the incredible cyclical engineering journey that's always happening just behind the scenes. What other tech will you look at a little differently now?